All right, guys, so far we've talked about naming organic compounds and a little bit about what organic compounds are, as well as isomers. Now we're going to look at functional groups in organic chemistry. So a functional group. These are the side groups, and they replace a hydrogen. Let me erase that. That replace a hydrogen atom in a hydrocarbon. And this is different than an alkyl group, but our same naming rules apply when it comes to like the numbering. So same naming rules apply. So a functional group is a side group that we add on to a hydrocarbon. So let's look at halides. Again, guys, all of the functional groups are in your reference table. So you will have these there for you guys. So you don't need to necessarily memorize what the branches look like, but we're just going to talk about what they are. So halides, we know that this is group 17 from our periodic table. So it's when a halogen, so group 17, replaces one or more hydrogens. All right, so we use a number for the location, of the halogen. So, for example, so we have our halogens over here, right? So for fluorine, we would label this when we get to naming, we would call this fluoro. Chlorine, we would do chloro. Bromine would be bromo. And iodine would be iodo. Okay? So, all right, so let's look at some examples of halides. So we have 3-iodoheptane. So this number here is telling us where on the parent chain the functional group occurs. So iodo is our functional group. And heptane is our parent chain. So let's start with our parent chain. So we have heptane, so we know that's going to be 7 carbons. So we'll do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And we have iodo, so that's telling us it's iodine, and it's on our 3rd carbon. So again, you can count from the left or the right. I'm going to count from the left, so I'm going to put my iodine right here. So that's going to be carbon 3, right? So 3, carbon 3, we'll put a 3 there, right? And then we're going to fill in the hydrogens everywhere else, right? Put a hydrogen there. So let me erase this 3. So we fill in our hydrogens. And now we have 3-iodoheptane. Okay? So our next example we're going to look at is 3-bromo, 2-fluoropentane. So 3-bromo, 2-fluoropentane. Pent meaning 5, so that's going to be our parent chain. So let's draw our 5 carbons. 1, 2, 3, 4, 5. And we'll start with bromo. So bromo, so we're going to put a bromine on the 3rd carbon. Again, I'm going to start counting from the left. So I'm going to put my bromine right here. Okay. So now we have 2-fluoro. So that means fluorine goes on my 2nd carbon. Now, pentene is 5. It's an odd number. 3 is smack in the middle. You could put your fluorine here or here, and either way that would be 2, but because I like to count from left to right, I'm going to use this carbon as my 2nd carbon. Okay? So after that, we fill in our hydrogens. And we end up with 3-bromo, 2-fluoropentane. Okay, so a halide group or halide functional group is just adding in any of the elements from group 17 are halogens. So let's look at our next one, which is our alcohols. So this is what the functional group looks like over here. R is the parent chain, and OH is what's going to be coming off the side. That's your functional group. So an alcohol is when a hydroxyl group is your OH attaches to the carbon chain. Again, we use a number to tell us where the location is. Number used to determine location. Of hydroxyl. Only if it's 3 or more carbons long. Okay, and our ending for when we're naming alcohols, the ending is going to change. We change the ending to all, all. Ending changes to all. All right, so let's take a look at an example here. So we're going to have 1 propanol and 2 butanol. So again, 1 propanol. Prop means that it's 3 carbons long, right? So 3 carbons. And this OL is telling us that it is an alcohol. So we know that it's propanol. We know that it's 3 carbons long. So we're going to go 1, 2, 3. And our alcohol is on the 1. So we're going to put our OH right here. And then we're going to fill in our hydrogens like we typically do. Okay, so now we have propanol, 1 propanol. Right, so the primary alcohol that the OH is bonded to is attached to another carbon. So let's look at our butanol. So but means 4, and our alcohol is going to be on number 2. So we have that there. So let's draw our parent chain. So 1, 2, 3, 4. So we were told that our alcohol is on the 2nd carbon. So again, we'll go right here. And then we'll fill in our H's here. Notice how I'm just writing it as OH. You could write it as, so 1, 2, 3, 4. We could write it as OH if you wanted to, but for simplicity's sake, we write it typically like this. So let me fill in the rest of my H's. And this is considered a secondary alcohol. So it is a carbon that an OH attaches to is attached to 2 other carbon atoms. All right, so that's halides and alcohols. We're going to look at ethers next. So ethers. So you either get organic chemistry or you don't. I had to throw in some jokes here and there. So again, the R's are your chain and the O is what makes it an ether. So it's an oxygen connected to 2 alkyl groups. So an oxygen connected to 2 alkyl groups. So we name the alkyl group first. So name the alkyl group. Either methyl or ethyl. Remember our alkyl groups from the other lesson. And then we follow it up with the word ether. So our ethers, let's take a look at 3 examples for this one. So we have ethyl methyl ether. That's our first one. So let's break this down. So ethyl is 2 carbons, right? So it's C2H5. Methyl is 1 carbon, so it's CH3. And then ether. This is our little oxygen there. So what this is telling you is that one ethyl, so C2H5, is connected to a methyl by an oxygen in the middle. Okay, so we have our ethyl group here, our methyl group here, and our ether in the middle. So let's look at the other one. So dimethyl ether. Take a notice here. Dimethyl. So we're going to have 2 methyl groups. So we're going to keep methyl in yellow. So we're going to have CH3, CH3, and then we're going to keep our ethers green. We're going to have our oxygen connecting in the middle for our ether. Again, we have diethyl, so we have 2 ethyls connected by an oxygen. So remember, our ethyls are C2H5, and then C2H5, and then we follow it up with our ether in the middle, and there you go. So we need to make sure we're remembering these alkyl groups, so ethyl and methyl. So if you had methanol, so if we had, let's pick a different color. If we had methanol, or sorry, not methanol, methane, I'm thinking alcohols, we'd have CH4. But our methyl is going to be 1 less, so it's going to be CH3. So just keep this in mind for the alkyl groups. Okay. Now, we're going to, again, this is just a very brief overview of the different types of functional groups. I'm going to post an additional video for you guys to watch that talks a little bit more about them in depth. I'm just trying to show you guys the structure and how we write them. So let's take a look at aldehydes. So an aldehyde is an oxygen that's double bonded to the first carbon. So an oxygen double bonded to the first carbon on the parent chain. Okay, and our name ending, alcohol was all OL, and our ending for aldehydes is AL, AL. Okay, so again, this right here, the RC, this is our parent chain. And then this is your first carbon in the chain. So let's look at the structure. So we have butanol. So remember that but means 4. And our Al here means it is an aldehyde. So let's start by setting up our parent chain. So 1, 2, 3, 4. And we said on the previous slide that an aldehyde is an oxygen that's double bonded to our first carbon. Again, you can start counting left to right, or you can count right to left. It's entirely up to you. Just make sure you are consistent with which direction you work with. So I'm going to stay on the left because that's what I'm used to. So I'm going to put my oxygen right here. So I have a double bonded oxygen. And now I'm going to go and fill in the rest of my hydrogen. So we're going to have 1 hydrogen here. And then we're going to fill in everybody else. And that's butanol. So it's a double bonded oxygen connected to the first carbon in your parent chain. So we have carbon 1, 2, 3, 4. And then everybody else is filled in. So let's look at heptanol. So hept is 7. And Al is our aldehyde, right? So let's do our 7 carbons. 1, 2, 3, 4, 5, 6, 7. These are always going to be connected to the first carbon, so we don't have to write like 1 heptanol kind of thing. So our first one, we're going to put this guy right over here. And then we're going to fill in our hydrogens. So many hydrogens. This is typically why we won't write the H's. We'll just leave dashes, but I'm doing the H's to show you guys everything along the way. All right, good. So the difference between an aldehyde and an alcohol is an aldehyde ends with Al, and it's a double bonded oxygen, whereas alcohols previously we said ended with Ol, and it is a single bond oxygen hydrogen or hydroxyl group attached to the end. So let's take a look at ketones. So ketones are oxygen atoms right over here. So oxygen atoms, double bonded. Notice the double bond right there. To a carbon, not at the end of the chain. So this could be anywhere in the middle of a chain. Okay, so it needs to be at least 3 carbons long. And we change our ending to -one. Okay, and again, because these are not on the first carbon, it's somewhere in the middle, we're going to use a number to tell us where it is. Indicate the location of the oxygen. Okay. So, ketone examples. So, 3-hexanone. The one is telling us that it is a ketone. Hex is telling us that it is 6. So let's draw our parent chain. So 1, 2, 3, 4, 5, 6. And we're looking for 3. I'm going to do carbon 1, 2, 3. I'm going to put my double bonded oxygen right there. And then I'm going to go through and fill in all my hydrogens. Now the middle guy who has the double bonded oxygen does not get a hydrogen because it has all 4 of its bonds that it's looking for. So it doesn't need an extra bond up here. We have 1, 2, 3, 4, so it's happy. Okay, so let's look at a longer one. So we have 2-octanone. So it's a ketone with the ketone location on the second carbon. And we have oct, which means 8. So let's draw out our 8 carbon. So 1, 2, 3, 4, 5, 6, 7, 8. And as usual, I'm going to count left to right. So I'm going to put my double bond here. And just for the sake of time and effort, I'm just going to do dashes for my hydrogens. So we're going to put all of our hydrogens in, make sure everybody has 4 bonds and nice and happy. And right here we have 1, 2, 3, 4. So we're good there. So the difference between a ketone and an aldehyde is they're both double bonded oxygens, but an aldehyde, so an aldehyde, the double bonded oxygen is on the first carbon, whereas in a ketone, the double bonded oxygen is on any one but the first. Anywhere but the first carbon. Okay, so let's take a look at organic acids. We have a couple more to go through. I hope we can get through it in the time, so let's see what we could do. All right, organic acids. So again, your structural form here, these are all in your reference table as well. So we have an oxygen, double bonded to a carbon. And these both have to happen for it to be an organic acid. A hydroxyl group. So remember, OH is our hydroxyl group. bonded to the same carbon. Okay, it is always, always, always at the end of the chain. Okay, and we change our ending to oic acid. This is how we determine that it's acid. So there's also two ways we can show this. So we have our structure over here. So this is our structure, but we can also write it out as chew or ku. Okay, so that's what your ending pretty much looks like. So let's take a look at an example. So we're going to look at one example here just for the sake of time. Again, I have another video, a separate video on functional groups for you guys to watch. So pent is 5, right? So 5, and then we have our ending here, oic acid. So this is telling us that we have that double bonded oxygen and that hydroxyl group. So let's build our parent. So 1, 2, 3, 4, 5. And let's make it an acid. So it's always going to be on one of the end carbons. It doesn't matter. So there's our double bonded oxygen and our hydroxyl group. And we're going to fill in our hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we're going to fill in all of our hydrogens. Everybody's happy. And what I showed you guys on the last slide, this part, I'll show you where that comes into play. We can also write this the condensed way as CH3, CH2, 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 COOH. So this is just our condensed form, but I wanted you guys to see where this comes into play. Okay. So let's take a look at esters next. Okay, so this is an oxygen that's double bonded to a carbon atom. With an oxygen bonded to the same carbon atom. Bonded to the same carbon atom. You can see that here, and then this R means there's more carbons going that way. So this is a reaction. This is the result of a reaction between an acid and an alcohol, and this will be discussed more in the next lesson. And this is where we get our smells and our flavorings from, and perfumes and even like artificial flavorings for food. And then let's take a peek at an example of an ester. So the reaction here, this is supposed to be an arrow. So we're going to have a reaction between ethanol and butanoic acid, and that's going to give us ethyl butanoate. So our ending here is O8. Okay, so let's start with ethanol. So ethanol, just so we remember, is an alcohol. Those are all my H's. We're going to add that with butanoic acid. So we have our 4 carbons and that double bonded oxygen and hydroxyl group. And then all of our hydrogens there. And then this is going to give us ethyl butanoate. So we're going to put that ethyl on one side, our oxygen in the middle, then that's bonded to a carbon that has a double bonded oxygen on it. Then we're going to put the butanoic, the part that comes from the butanoic acid. So we have 1, 2, 3, and then these are all going to be hydrogens. And it looks like everybody's happy. And then one of the products is water as well. But your ester is this guy right here. So that's our nice big ethyl butanoate. Okay, so the way we name this is we name that alkyl group. So we're going to name alkyl group that's next to the oxygen. That single bond oxygen first. Then we're going to follow that up with the parent chain. Okay, and we're going to remove alkane from the end and add O8 to the end there. Esters are a little complicated. We're going to talk about them more in the next lesson when we talk about reaction types. We have 2 more we should be able to get through before the time runs out, and then I'll post this for you guys. Okay, so amines or amines, however you want to say it. So this is a nitrogen atom bonded to a carbon chain. We drop the ending. We drop ending and change it to amine. Okay, so let's take an example here. So 2-pentamine. So 2 is where our amine is going to be, and pent is our parent chain, meaning 5. So we're going to do our 5 carbons, 3, 4, 5. And we're going to put our amine group here. These are going to be H's. And then we're going to fill in all of our other hydrogens as well. Okay, so we're just adding an amine group to the end of it. That's this guy here. And again, we will use the number to tell you where. And the next one, which is not that different, is our amides. So it is still a nitrogen atom bonded to a carbon with the same carbon double bonded to an oxygen. To a carbon with the same carbon double bonded to an oxygen. So we name the parent chain first, drop the ending, and we add amide. The last one was amine, this one is amide, and this is what our functional group looks like here. It's going to be this group there. So let's look at our example before we run out of time. So hex means 6, right? And then we have amide telling us it's that double bond oxygen and nitrogen group. So let's build our first 6. 1, 2, 3, 4, 5, 6. And then let's add in our amine group. So it's going to be on our last carbon, one of our end carbons. And we have our nitrogen with our hydrogens. And then everybody else gets their happy 4 bonds by adding hydrogens in, right? This guy's happy over here on the end. So we have our amide group that hangs out over here on top of our parent chain. And that's always going to be at the end. Always on an end carbon. All right, so that's the difference between an amine and an amide. Amine and an amide. It's a very difficult language sometimes. Don't fret too much about this stuff. I know this was very quick for all these different functional groups. I have another video linked for you guys to watch that's going to give you a little bit more in depth on like the uses of these functional groups as well. And we will talk about these more in the next lesson, which will be on reactions. So that one might take a little bit longer, or it might be 2 parts. But just so you guys know, I forgot to mention it before, all of these functional groups are located on table R in your reference table. And that's on page 8. So you don't need to memorize the functional groups or the general formulas. So the general formulas were where it said R dash whatever the functional group was. So again, you don't need to have these memorized because they are there for you in your reference table. So I hope you guys are well. I hope this isn't too difficult or too crazy for you all. Keep an eye out for lesson 4 and additional resources that I'll post for you all. All right, guys, good luck. Keep me posted with any questions and get through all your work the best you can.